September 3rd, 2025. We got a new wood stove setup, and I'm going to go over how it works. On the bottom here, we have the secondary airflow. It goes in under the stove and comes out at the top of the firebox. I've got a couple of holes on the riser tube to give more primary air in the back of the stove. On the left, we have the control box, and that's operating the two fans. The second fan is the primary air fan. It's up on the top left there. It's putting in that plenum tube, and then it goes into the top of the stove. This particular stove has vents right above the door, and we have to put air in there. Otherwise, the fans push it out those vents, and that's why I had to put that plenum tube on there. And then on the back is the convection air that pumps air behind the stove and out the top, and we were getting 125-degree air today. This is the secondary air fan. It puts out around 7 CFM at max, and it is modulated. This is the primary air. It puts out a max of around 4 and is important to keep the flames yellow. It is also modulated. They both spin up at the same time. They just put out slightly different amounts of air, and they also put air in different locations into the firebox. Part of our instrumentation suite is this Dwyer Mark II. I have it zeroed at 0.05 because sometimes it can go negative a little bit. This helps me keep track of the fans and if they're putting too much air pressure in or if the exhaust system is pulling too hard. Another day and some more testing working on our smoke measurement system. One of the most difficult things is when you put one large log on a fire. Now, if you do it with a very dry log and the wood stove is cherry red hot. When I say cherry red hot, the coals are cherry red. They're glowing brightly, and the stove is over 300 degrees Fahrenheit, regardless of where you measure it. So if those two conditions exist, you can just put a log on and it will burn just fine. Our log is a dry cedar log. It's still got bark on it. It's 1.6 kilograms, about 3.2 pounds, and 11% moisture content. Typically, you're going to have trouble with a log if it's a little wet. What happens is the outside will burn, and then the inside just smolders for hours, causing lots of smoke. So you got to be able to break it up, and sometimes the logs have to burn so long before you can actually break up the material. That's why logs tend to smoke for a good period of time and a good test of the smoke measurement system. I have two charts up. I put the log on at about 1.5 hours, and you can clearly see a stack temperature rise. That's the red line on the top. The wood stove stays warm. In fact, has a small peak between 1.5 and 2 hours, but generally just declines in temperature down to around 250 before I put one more scrap of kindling on. So you can match that with the graph below in that about a half hour to 1 hour when I was getting the stove warm, getting it heated up. It was putting out some smoke, not much. I'll go over that opacity peak in a minute, but for the most part, when we put the log on, it burns pretty clean. And it wasn't till the tail end and just before I put the kindling on at 3 hours that we see a little bit of smoke from the log that just is in a very small carcass of what it was. But they tend to smoke until you can get them broken up. This section of chart is the longest and highest, the one that reaches 20%, and I don't think we really exceeded 20% for 6 consecutive minutes. 6 consecutive minutes is considered the legal limit for exceeding 20%, and my device is good to around 0.1%, and I'm seeing a few small peaks that go over 20%, but then they drop back down. And this whole peak between 39 and 42 seconds is only 4 minutes. So we have 4 minutes that are near 20%, but not 6 minutes that are over 20%. I was once asked why a log doesn't burn outside a wood stove, but when you put it in a wood stove, why does it burn? It comes down to the temperature of the physical walls of the interior of the wood stove and the coals. If we assume that everything inside the wood stove is 500 degrees Fahrenheit when we insert the log, then we have a heat flux that would estimate it to be 4.5 kilowatts per square meter to the log that is going to be burned. This is enough to ignite it, and you can see when this log goes in, it doesn't take too long for the surface of the log to ignite. So 2.0 kilowatts is considered flashover in a room fire, where the fire is enough to ignite combustible items on the floor. We exceed that by almost double inside a wood stove. This is why new fuel placed into a hot enough wood stove will catch fire almost immediately. Clean burner burns a little cleaner. Clean burner, air is much greener. Neighbors all know the smokeless stack. Smokeless stack, no soot falling back. Hey. Clean burn stove heats every room, yeah. Clean burn stove avoids a rainy gloom, yeah. Clean burn stove, no wasted wood now. Clean burn stove, burns as it should now. Clean burn fire, efficient heat now. Clean burn fire, efficient heat now.